Okay. So, now what we are going to see is, we are going to see the solution to the hash table question. So, let us go over this question once again. What does it say? A hash table is a data structure that maps a set of keys to a given set of values. It uses a hash function to compute an index into an array of buckets or slots, okay, from which the correct value can be found or to which a correct value can be inserted. A hash function will assign each key to a unique bucket or slot. In practice, however, there are many more than one key that will hash to the same bucket. Such an assignment is said to result in a collision. Okay. In this assignment, you have to implement a hash table using arrays and linked lists. The algorithm should accommodate the features described. It should take as input a set of 10 non-negative integers and insert them into a hash table using this hash function, where h of x is equal to x percent 10. Okay. Then input values that return the same value for h of x have to be properly accommodated, such that if there is a collision, the index from the array to the appropriate bucket should point to a list that can take in all the values that hash to the same bucket. So, basically what you need is, you need an array of lists such that each entry of the array is a pointer to a bucket. For example, when h of x returns 4, the input value should go into the list starting from A4, okay, if A is your hash table. Okay. Your program should report when there is a collision and must specify the position starting at 1 for the first element in the input list of that key value where the collision occurred. You should also report the bucket number and the number of entries in the bucket, and if there are no collisions, the program should report no collision. Okay. The hash table class has been provided with a print collision function which you cannot rewrite. Okay. What you have to do is, the string that you want to print has to be made available in the private data variable collision using list collision function in the class hash table. So, let us see how this can be implemented. So, basically the constraints of the keys are, it can be a value between 0 and 1000, and if you take a sample input like this, what is it that we are saying? You have 77, 23, 231, 785, 900, 345, 287, 16, 5 and 24. Okay. So, when you look at this 77, for example, when you take percent 10, it goes into the 7th bucket, it is the first element, there is no collision. Okay. Let me go to the board and give this example again for your ready reference. Okay. So, what do we have here? We have 77 and let me read the numbers over here: 77, 23, 231, 785, 1, 785, 900, and then I will just go this first example, 345. Okay. So, this is the key. So, what happens when you take this 77% 10, this gives you a value of 7. This 23% 10 will give you a value of 3. 231% 10 gives you a value of 1, and 785% 10 gives you a value of 5. 900% 10 gives you a value of 0. 345% 10 gives you a value of 5. So, now I am stopping with this because now what has happened? Okay. So, what did we see now? 77 hashes to an index of 7, 23 will hash to an index of 3, 231 will hash to an index of 1, 785 hashes to an index of 5, 900 to 0, 345 to 5. So, what do we have now? We have an array of, first we have to define an array. Now, in this array, what are the, how many elements do we have? We have 10 elements in the array. Two, 3, 4, 5, 6, 7, 8, and we call this a bucket. Okay. Each one of the indices of this array is called a bucket because it actually holds more than one value. So now what are we going to do? We said we have to store these keys in this hash table. So this is the hash table. Okay. Now the problem is because we have only 10 entries in the hash table, clearly because you are talking about 0 through 999 as the numbers that are possible, you have more than 10 values, and therefore many numbers will hash to the same bucket. Okay. So and that is the meaning of a collision, as we already saw. So now let us see where will we put 77. We will put 77 over here. So we create a list at this point and put 77 over here. Okay. 23 will go into the third bucket, we put it over here. Okay. Then 231 will go into the first bucket. So far so good, there are no collisions. Okay. 785 will go into the fifth bucket. This is 785 over here. The 900 will go into the 0th bucket because the remainder is 0. Okay. And we have still not seen any collision. Now 345 comes along and we have a collision. Okay. So what is the collision now? So now at 340, notice that it remainder is 5, therefore it goes into the fifth bucket. We already have one element, so we append this to the list. Okay. So what is this now here? Notice that each element of the bucket is a list. This implementation of the list can be done either using an array or a linked list. The list ADT is what you need to use over there. Now what are you supposed to report? You are supposed to report the index in the element in the input list. So the input list I gave 77, 23, 231, 785, 900 and 345. So if you look at the numbers over here, so this is the sixth element in the list where the collision has occurred. And what is the bucket index? The index is 5. And how many elements are there in that particular bucket? There are 2 elements. So now, and you are supposed to report the result like this, 6, 5, comma 2, and that is what is given in the sample output. And there are more examples that are given in this in the question that has been given to you. Okay, so let us look at a solution to this particular program. So this is kind of similar to the ADT that was done in the lectures on the list. So basically you have a linked list representation here, and position points, something points to the list head. In addition to that, a new variable has been defined in the called count in the list. So it gives you the number of elements in the list. Okay. Suppose count was not there, what would you do? You would write a function to count the number of elements in the list by traversing the list from the beginning to the end. Okay. Then make an empty list, creates a null node and insert elements into the list, find the end of the list, all of them are the same. Get count returns the number of elements in a given list. So let us look at a class hash table now. What does the class hash table contain now? Notice this variable here, list bucket of 10. That means it's an array of lists. Then it gives you the bucket index, number of element bucket and position in the where you want to insert in the particular bucket, and a string, a collision which you are supposed to fill corresponding to the collision which you are supposed to fill up. And report call, this is required because they also say you have to print no if there has been a no collision. Okay. So what are we doing now? Initially, because the hash table is empty, we set the counter in the hash table, the count for example, to 0 for every one of the list. We have an array of lists. How many do we have? We have 10 elements in the array, and the counter in every element in the list, every element of the bucket hash table corresponding to the bucket is set to 0. Okay. Then what are we doing? To insert an element, we find the bucket index, that is as defined in the private variable. So once we get the bucket index, and what we do, we create an empty list if the count is 0, that means there is no list over there. Then we find the position to insert and insert it at the end of the list. Okay. Then what are we doing? We get the the number elements in the bucket, basically at what position it has to be inserted in the given bucket, okay, and you return the number of elements in the given bucket, okay. That is what the insert function does, slight variant of the insert that was done, okay. And once you have this, you are all done. Then list collision, what are you doing? You are giving the position where the collision occurred, the bucket index and the number of elements in the bucket. That is all you need to do. So, basically this is what you have to fill up, okay. There is no big deal over here. There is a string to which you are basically concatenating the position and the bucket index and the number of elements in the index, okay. And the print collision will take care of it, okay. Then what is happening here? The print collision function is given, and what does the print collision do? If for example, there was a Boolean variable called report call, basically there is no collision that occurs, then it will print a no over there, okay. So, this is essentially what this ADT is all about. So, what are we doing here? Basically, you are supposed to list the collisions that occur in the given data set, as you have seen in the example. So, let us run this with the given example over here. Table, and let us say I gave 21, 32, 33, 41, 45, 663, 71, 88. 7, 86. Okay. So, what is it telling me now? 21 for example will hash to bucket 1, 32 will hash to bucket 2 and 33 will hash to bucket 3. So far no collision, but when 41 comes along it hashes to the bucket 1 again, and what does it do? It gives you, so 41 is the 1, 2, 3, 4th element, therefore the first index is 4 here, and then what happens? You have it is the bucket number 1 and the number of elements so far in that bucket are 21 and 41, which is 2. Okay. Then 45 again hashes to bucket 5, no collision. Then what happens? 663 hashes to bucket 3 and therefore there is a collision. Therefore, this is the 6th element, 3rd bucket, and now there are 2 elements because 33 and 663. Next, what is happening? You have 71. Now 71 will hash to 1 again. So, now this is the 7th element in the list, hashes to the first bucket, but now 21, 41, 71, there are 3 elements in the list. So, this completes the solution for the hash table problem. So, next we will look at the solution for the big int problem. Okay. Let us look at the big int problem. And we will just see how this is getting done. So, what is this big int now? You are asked to find a sum of 2 large numbers. Here again another implementation of the list is given, okay, a different implementation, and you are supposed to use this implementation of list to perform big int arithmetic. So, what is being done here? Let us see. So, what are we doing? To perform big int arithmetic, what is suggested is you have to implement a class called big int now, and within this class you are using a private variable list, just like we did the stack from the list. And what are you doing? You are appending a given number, prefixing a big int number, and you have to perform this add operation and print. Okay. If you want, you can have, suppose there are leading zeros, you can remove it or whatever. So, what are we doing now? The first function that is given to you is a populate, and you are supposed to write your code here. So, what are we doing? As I mentioned previously, we read the big integers. Okay. This is a big int 1 and this is a big int 2, we read them as strings, and what is being done in this particular program, something clever is being done. What is done is, after all, what is the big int using? It is using a list, right. So, what we are doing is we are inserting every time. So, I am reading from left to right. As soon as you read this element, I put it in the first position. Next 9 is put in the first position. So actually what is represented in the big int is, I will tell you why it is being done like this. 6, 5, 4, 3, 2, 1 and 0. It is written like this. Okay. And similarly, this other number here is written as 1, 2 is inserted into this is list. Okay. 1, 2, 3, 4, 5, 6, 4, 1, 2 and 3 and 5. The reason for this is both of these, let me rewrite this again. What we are doing is, in fact, this is the starting point in list 1. So let me call this list 1 or the big int 1 and this is L2. So what's being done is, I store 1, 2, 3, 4, 5, 6, 4, 1, 2, 3 and 5. The reason for doing this is that when you add two numbers, remember, we have to add from the least significant number position. Okay. So what happens is when these two are there at the beginning, you can add these and propagate the carry. Okay. Once you propagate the carry, what you will do now? So you add these two numbers. Okay. This gives you 1, there is no carry. 2 plus 1, so I put it back over here. This is create a new list, let us say 3, 1, 3, 5, 7, 9. Now there is 11 here. So now this 1 should be added to these two elements, 6 plus 4, 10, 10 plus 1, 11. And there is one more here, 9 here, 9 plus 2, 11 and this becomes 12. And then finally this 5 has to be added to the carry and should give you 6. Okay. So this is what the two numbers should be. So what are we saying? 0 plus 1 is 1, 2 plus 1 is 3, 3 plus 2 is 5, 4 plus 3 is 7, 9, 11. Therefore, this becomes 6 plus 5, 11 over here and 1 is carried. So, 6 plus 2, oh, I wrote the number wrong over here, so 5, 6, 7, 9 and 8. So, what did we do here? 0, 6 plus 5, 11. Where were we here now? So, basically 0 and 1, 1 and 2, 2 and 3, 5, 7, 4 and 5, 9, 6 plus 5, 11. This is what is happening here. Then after the 6 and 5 have been added, I get 11. Therefore, 1 is the carry. Okay. Then after I have carried the 1 here, I have here 6 plus 1, 7, 7 plus 4, 11 again here. Then again there is one more carry, 7 plus 1, 8 gives you a 9, okay, because a carry there, and then 9 plus 2, 11 and there is a carry there, and then we have 8 plus 3, 11 plus 1 carry makes it 12, and finally this number which is longer than the second number is longer than the first number, you add a carry to it. Okay. So, essentially you should get this particular result, but the result is in the reverse order. Okay. So, basically finally 5 plus 1, 6 is what you are supposed to get. So, this should be the result of the number, but it is in the reverse order. So, what is done in this particular program, if you look at it, is to make this convenient, because you can start from the beginning of the list, the population of the integer is done such that you prepend, put it in the beginning. Okay. Then there are basically there are two functions, append and prepend, which are given here, how you are supposed to write it. Then you add. So, what do you need now when you are adding, because you are adding two elements at a time, there will be a remainder and a carry, which is represented by this. And what are temp1 and temp2? Temp1 and temp2 correspond to the two lists which represent the two numbers. So, the first part, what is done is, while both of them are the same length, okay, till that is what is done is, while temp1 not equal to null and temp2 not equal to null, what is being done is you get the data from both these lists, you find a remainder, you find a carry, then you append it to another list, and you keep on repeating this process until you come to the end of at least one of the lists. Then what you do is, as I said, in this particular case, for example, list 1 ended first and then list 2 ends later. So, you check which one ends first, which one ends later, and if there is a carry, you add the carry also. Same thing is done for if the other one ended first and the carry is appended. Okay. Then if you want, you can remove the leading zeros if they are there because we are writing it in reverse order. And basically what is done in this main program, as was told, you are not supposed to write this function, you are supposed to populate the string A corresponding big int A, big int B, and then perform the add of the two of them and print them. So, let us run this program. Okay. Okay. What does it expect now? Let me let us say 1111. So, here I gave two reasonably big integers 1111, 22222, and it gives me this. Let us run it again and let me give 9999 and give 1. Then it gives you, notice that 9999, these are two numbers. This one, the one given above is a big int and other one has only 1, but 9 plus 1 10. So, what happens? There is a carry and that is added to the next number and so on, this is repeated. Okay. So, this is the big solution to the big int problem. Okay. So, what we have looked at is the solutions to two of the problems that have been given as part of the data structures week 5 assignments, if I remember right.